Hey you guys, here's a little help video for a titration question. So this question is one of your quiz questions or exam questions, and it's really looking at a titration question. A titration is where you add a known amount of a standard solution to maybe something that's unknown. In this example, it's a common acid-base titration. And if you look at the balanced chemical equation that's given here, that should be an arrow in the middle, by the way. So if I look here, there should be an arrow right there. And in this question, it's saying it is what's called a diprotic acid. And a diprotic acid is something that has two hydrogens attached to the anion, which makes it capable of donating two hydrogens to a base, for example. So anyway, that's what's happening here. This balanced chemical equation is saying this diprotic acid reacts with a base and then makes a salt and water. Remember, water is right there, and then this is the salt. The endpoint of the titration is given. The endpoint of titration of a certain liter sample of aqueous H2X was reached by the addition of this many milliliters of this many MOH. So I always find that it's a good idea to write it again. H2X plus 2 MOH. This means it is balanced. We want to make sure it's balanced to make 2 waters. And then plus M2X, and that's the salt. So if this completely reacts and you perfect titration, you will have basically a salt solution, whatever salt this is, assuming that the salt is soluble in water. So anyway, let's write down what we're given. The endpoint in a titration of a certain milliliter sample of aqueous H2X. So we're given the volume of our sample. So here's the bucket. And the bucket has H2X in it. And then that is 0.012 liters. So 0.0120 liters. There we go. That's the volume of that. Was reached. Now we had to add. So we added so many milliliters. How many milliliters? It looks like 32.5 milliliters of a certain molarity of sodium hydroxide. And it looks like it's 0.370, 0.3700 molar. It's not sodium hydroxide, it's M. This M could be potassium, it could be lithium, it could be sodium, it could be many different hydroxides, as long as it's monovalent, which would be +1. So anyway, remember molarity is the same as, it's a concentration unit, it's moles per liter. So if I want to know, I added a certain amount of volume and I have a certain molarity and I want to know how many moles that delivered, I could use my molarity relationship, which is molarity equals moles of solute divided by liters of solution. Now I have the liters and I have the molarity. I want to get moles. So in order to use this properly though, and not try to add apples and oranges, I need to convert my milliliters to liters. To do that, I would move it over 3 points. And now it becomes liters. So what do I need to do to these things? I can just put them in here, and now I have 0.3700. Now I personally like to teach this more as a dimensional analysis idea, because this is moles per 1 liter. And say I forgot this relationship over here, I could just multiply this by the number of liters. So 0.0325 liters, and then see my liters cancel out. So I can go get my handy calculator, and I can say 0.32 times 0.0325. Oh, I'm sorry, that was a 7. 0.37 times 0.0325. Here we go. And now I have a certain number of moles. 0.01205 moles. Now I'm carrying all the significant digits to the very end, or all the digits to the very end, so I round to the number of significant figures. But remember, what is the question? What is the molarity of H2X? So in this bucket, there was a certain molarity of that. Now I got to figure out what that is. Well, remember, molarity is moles per liter. Well, I have the liters right here. And now I have the moles. So I can plug them into this relationship, moles, liters. So I'm going to take that number, I'm going to divide it by 0.012 liters. My answer is the molarity of this substance is M equals 1.003 or 1, about 1. How many sig figs do we have? Looks like the minimum one we have is maybe right here. So 3 sig figs, so I'm going for a 3 for a couple here. There. That's the molarity of what? The H2X. So there you have it. That's how you would determine the molarity of the unknown. I hope that was helpful.